So, welcome everybody to a new round and to the topic of today, maximizing energy efficiency in manufacturing. I brought today a colleague of mine, Tobias. He is our customer success manager, and he will lead you through today's topic. And having said this, I will hand over to Tobias. Tobias, go ahead.
Yeah, thank you very much, Gerrit, for the introduction, and also a warm welcome from my side. Thank you for joining me on today's webinar about maximizing energy efficiency in manufacturing. In preparation to this webinar, I was asking myself, why are we talking about this topic? Why is it so important? Because I think we are all aware of the uncertainty of the energy prices due to the events in the recent years. That the ESG regulations and also other norms are getting stricter every year, and that sustainability is rightfully getting more and more important also when it comes to brand value and reputation. On the other hand, the energy consumption of the production is still a big mystery for a lot of companies. And I think the question from my last webinar in November last year is still really fitting here, because it's often about the data transparency that is still missing to actually identify the energy saving potentials that industry analysts like Gartner consider possible. And I think it's this split between the need to fulfill these expectations versus the current state of implementation we see in the industry today that makes it such an important topic at the moment, and something to talk about. Today, I will present to you two case studies of our customers. The first one is actually a customer that got proactive to fulfill sustainability norms and wanted to get the ISO 50001 certification, and is now also saving about 350,000 euros annually on energy consumption. And our second case study is actually a really interesting one, I think a really inspiring one, highlighting the innovation speed you can gain if you have set yourself up in the right way, which we will look at later. Because after these two case studies, we will dive into what we have learned from these two case studies and also projects with other customers in what makes an energy management initiative successful. As a customer success manager here at Cybus, I have the privilege to actually work closely with our customers, often also visiting their production facilities and getting firsthand insights into the challenges they face when it comes to digitizing their factories and hopefully then solving these challenges alongside them. But before we dive into the first case study, I want to ask you the question: where does your current company currently stand when it comes to energy management? I want to encourage you to just quickly use the poll you just see to actually choose an answer there, and let's see where it goes. So the first ones are already coming in. Let's wait a little bit more, like almost a minute, to see all the answers. We actually have a kind of even race here, a little bit more on the just getting started, which is actually great to see. But there are already also some that have an advanced implementation in place. Okay, let's wait for some more answers. Okay, I think there are no more answers coming in. So let's maybe end the poll. So what we see is a lot of people are just getting started. They recognize the importance of energy management, but are in the early stages. Some don't have it at all in their company, which is also something we see quite a lot. And I would be really interested to talk to the one who told us to see the advanced implementation. I think there's a lot to learn from both sides here. Now, Gerrit, thank you. Back to the presentation. And let's dive into our first case study. But actually, wait, before we do that, I want to highlight the 3 steps we actually see to make these projects successful, which is building the right team. Then second, calculating the business value here to actually show the return of investment you can gain through this initiative. And the third one is choosing the right technical backbone to make this, the implementation of it in a short time and scale it also to multiple production sites. And I want you to keep these steps in mind as we're going through the case studies, because you might see some of the, you remember some of the projects you have done yourself, or can see some parallelities alongside that before we dive later deeper into the topics. So coming to our first case study, we have a company that is in the food and cosmetics sector, and they had a dedicated energy management person who set himself the challenge to actually proactively fulfill the ISO 50001 certification for the company. It wasn't mandatory at this time, and I'm not sure if it is, but I think it will follow soon. And to do that, he got involved with the IT department and closer the factory IT to actually set up a system, and also to the OT to deploy the needed sensors for that. Before they just deployed sensors everywhere, they actually started by identifying the biggest energy consumers in their factory, and found out that the factory, like the facilities themselves, taking up around 40% of their energy consumption. And with the facilities there, I mean the air pressure systems, the air filtration systems, and also the HVAC and the lighting itself. Having that identified, they could strategically place the energy counters to actually measure all of the energy consumption. After having that placed, they needed to standardize all of that data and collect it through a factory data hub before sending all of that to the energy management system. This dedicated energy management system then allowed them to further analyze the data and also fulfill all the needs that the ISO 50001 certification places on these companies. That also includes conducting yearly energy audits, where an external auditor comes in and looks at your energy management system, your action plan you have set yourself up for the upcoming years to save even more energy, and also looking at your consumption on the last year. So they now have the ISO 50001 certification, and they also have the yearly energy audits, and they of course then also need to analyze the energy consumption to actually gain any savings from that. And they found out that the most important thing for them is actually analyze it regarding the actual demand of energy, because they found out that a lot of their systems are running even through their through the weekends when they were not producing. They were only producing Mondays to Fridays, but the air pressure system and the filtration system and everything was running on the weekends as well. So turning that off actually made it possible to save around 20% on the energy. That is equivalent for them to around 350,000 euros annually. Throughout that process of implementing the ISO certification, they were also able to secure some funding from the German government to actually set up that use case. There are different funding ways, for example, for implementing an energy management system, but also the audits themselves get subsidized. So they could make the investment for them a little bit smaller as well. And now they have the factory data hub in place as a foundation for future use cases. Why that is important, we will come back to later as well. And they are now already planning the next use cases with this foundation in place. Coming to a second case study, and I already teased it as a little bit, yes, an innovative solution or creative solution there, and that goes a little bit beyond the shop floor. The company already has a factory data hub in place at their production facility, and they already have a lot of use cases implemented when it comes to their production, like the traceability, getting rid of all the paper trails they had before, and a lot of other stuff. And that was a really nice base they now have as in terms of data and also like interfaces between all of the systems. And that what they realized is that they are actually, that their office building is taking a lot of, consuming a lot of energy when it comes to heating. I guess their office building, at least from the outside, doesn't look as nice as on the bottom right picture here. And they were having a lot of problems with that. And before like insulating a whole office building, they thought we have this factory data hub in place. We have all of the systems connected and can access all of the data. Let's use this data to actually save some energy here. And they did that by placing smart thermostats in all of their offices and connected all of that to the factory data hub, having some thermometers in place to measure the temperature. And then they needed the data to when do we actually need to change the temperature there. And therefore, they used the SAP system they had connected for the room allocation. They had the working hours from their BDE system. And they also built a small web app to give the employees a better way to actually request temperature adjustments instead of just turning on and off the radiator. And also for the IT or for the facility management, they implemented a battery alarm to actually change out the batteries when they run low on the thermostats. And with that system in place, they are now able to adjust the heating in all of the rooms based on the employee presence and lowering the heating during the off hours. So turning off all of the thermostats when no one is there, on weekends, on holiday, and so on. And all of that led to long-term savings when it comes to the heating costs of their offices. And I think this is really important here because when it comes to energy management, we have to think about the earlier we implement that, the longer, like from that moment on, we save that money. It's not a one-time saving, but it's actually really long-term from that moment. So on the other hand, you could say like every month you wait or every year you wait to implement such a solution, you are still wasting a lot of potential there. And in their case, all of that was possible with almost no additional cost. They had all the interfaces already in place and just needed to buy the smart thermostats to actually control the temperature. So I think, yeah, this is a really good example on how you can get creative if you have all of that in place, have the data accessible, and don't have to bother about all of that stuff anymore. So let's now look at what are the best practices for large-scale energy management. And as I mentioned earlier, we start by building the right team. And building the right team means we have a cross-functional team consisting of people from the OT and also from the business perspective that have the actual data demand and drive these use cases. And we have the IT that actually governs all the data and makes it more secure and manageable. And we need all of these because we start at the shop floor. there we acquire all of the data. And the OT personnel, they actually have the expertise about all of the PLCs and the sensors where the data gets acquired. Then I think there's no real project possible anymore without having the IT on board. And the IT is actually who operate these solutions. They have the data governance and they configure all of the data flows from the shop floor into the different IT systems to meet all of the data demand from the business units. And the business, the business units come with a data demand. And I think you either have them directly in the team, or as we see it more often, the companies are now having dedicated data scientist teams to actually that actually serve as an internal service provider. So the people that actually have the business demand, they have a use case, can actually go to the data science team and say, hey, I'm responsible for the energy management and I need the following data. Can you provide it to me? And they actually talk within the team to acquire all the data from the OT, send it through the IT, and then also do the analysis and have some nice reports ready for the business, for the use case owners at the end. And this is a team at the end where you have all the expertise you need to actually make such an initiative successful. And it's important that you have this cross-functionality. And I think I have two anecdotes that actually showcase it really well. Because lately I got told from a customer that their data science team was really hyped to get their first analysis done. And they identified some anomalies in their data, because 3 times a day the production took a dip and less parts got produced. And they were really excited about this, about what they found out there. And when they presented it in a bigger round, no one really was surprised, especially from the OT, because they said, yeah, that's totally normal and expected because it's a shift change that is happening, like 3 times a day. And in that time, they make a little bit of a pause and less parts get produced. So I think here it's really important that the data scientists actually get some more context about what data are they analyzing there. And on the other hand, just last week, I talked to someone from the OT who told me he's amazed by the analysis he now gets from the dashboards and so on that the data science team is building. And he said, like, they were only a couple weeks into the project and he has not seen anything like that in like his 10 years of working in the OT. And I think these two stories highlight the best why it's important to have this cross-functionality and building that team from all the different areas. Which brings me to the second step, which I think is also really important. And as we see it oftentimes missed when it comes to these projects and these initiatives, which is actually calculating the business value. When it comes to energy management, I think it's a rather simple calculation to do there, to actually have some first idea. Of course, it's difficult later to actually say we have improved the energy consumption by this amount and saved therefore this amount of money. But in general, energy efficiency is rather easy to calculate here. But we often see that it's still not being done because like all of the digitalization initiatives get seen as we have to do that funding anyway. We don't really care about the return of investment because we know it's worth it. And they know it's worth it, but they haven't really calculated why or if it even is worth it. And that makes it harder when in the times we have at the moment, like the economy is not growing that much. We have sometimes the problem that there are some budget cuts, and if you cannot prove the business value you have there, it's not that uncommon that your budgets get cut as well. When it comes to energy efficiency, and I think my colleague Lukas Teilacker in an upcoming webinar will focus on it even more, is that business analysts say you can save around, or industry analysts say you can save around 5 to 15%. And if you just take the 5% and look how much energy is your company consuming, either per site or in total, and if you are able to achieve this 5% saving there, then calculate with the current, with your industry energy prices, how much savings would that be? And then you have to think about what I already told earlier, that all of the savings you can get done today are long-term savings. It's an ongoing saving you have there. And when we look at this at the slide here, it's shown that there's a lot more efficiency gains than just the energy consumption. And it's shown here because we think energy monitoring or energy management shouldn't be seen as a project in itself, but rather as a use case in the whole digitalization or smart factory journey of that company. Because a lot of the data that is needed for energy efficiency is also needed in other parts. For example, a couple of weeks ago, we had a factory tour by someone from the maintenance team, and he said one of the biggest problems he has is actually not knowing the state of the machine. Like all the, for you, if you have been in a shop floor, all of the machines have this, these signal towers, these signal lamps that show which status the machine has. Green is usually good, red is not so good, and yellow depends. And he said one of his biggest problems is that you see the light here, you go around the corner, you don't see it, and you don't know if the machine is still producing or if it's not. And this is the same data point as you would need to identify the energy efficiency for that machine, knowing which status it has when it's consuming that amount of energy. So you have the same data point actually fulfilling two use cases here. And that goes on for even more use cases. So having all of that data in a central place makes a lot of sense here. And that brings us to the next point, which is actually choosing the right technical backbone. And as I mentioned before, we are looking for a shared infrastructure, not looking for a single solution for a single use case, but an infrastructure that can grow with all the use cases, because that makes it way easier to actually get the budget. And here, another anecdote, like a lot of customers are saying, yeah, we have built use cases in the IIoT space before. We had one on this machine and one on that machine over there and another one here. And all of them took like a lot of effort to get the funding for that, to get all the people on board and build up this team. And then at the end, they were successful. They had this use case in place, but they weren't able to scale it. They weren't able to put it on the machine next to it. Not even speaking of like getting the energy management or something for the whole shop floor and even multiple production sites. And they were looking now for a solution to actually be scalable. And that is what is happening now, actually building one dedicated team for all of these use cases, having one infrastructure in place, and therefore building on top of that infrastructure one use case after the other, getting quickly into the return of investment of that solution, and then just growing the profit from there. And therefore, of course, if you want to grow the profit, you should calculate it as mentioned in the step before. But how does this technical solution, this technical backbone work? And of course, I would do it with our product, the Cybus Connectware, where we will show that is focused on the large scale configuration of these use cases. And usually it all starts with a business that is having some kind of data demand, some use case. In this case here, it's traceability. And we have some machines in the shop floor at the OT that actually can deliver the data. And then there's a lot of more use cases. For example, now we also have the energy management on top of there. And we then have a lot of machines to actually connect to and a lot of different IT systems to connect to. And that quickly leads to a big mess. You have a lot of connections ongoing. Everything is managed in a different way. And no one really has an overview of what is happening there, if it's all secure, and so on. And that is where a factory data hub comes into play, connecting all of the machines at the shop floor and connecting all of the IT assets at the top and delivering all of the data that is needed for the different use cases. So fulfilling the data demand of the business. And this, of course, should be scalable within the factory over the different use cases, but also scalable onto different production sites. And to achieve that, Cybus Connectware is really enabling the IT to use text-based configuration that is known from common DevOps principles in the software development. And they can describe how should this machine be connected, how should the data of this machine flow into which system, and how should it be pre-processed, maybe enriching the context before it leaves Connectware again into a cloud system. And all of that can be put into a central repository and then be rolled out into a CI/CD pipeline, which then automatically pushes all of this configuration into the system and connecting all of that at once. And this allows it to be really flexible, not only having that pipeline for just one system, but actually repurposing all of these files and implementing that on different production sites as well. So when it comes to energy management, you have like one, let's say, blueprint for this use case, and you push it on all of your machines. And then you can quickly go into different production sites and have the same repository, rolling it out to another instance of Connectware to connect all of the machines there. And we there really focus on giving the DevOps methodology that has been proven in the software development to the factory connectivity, because it just makes sense to have the to use what has been proven also in the manufacturing industry. And coming now to the end of my presentation, and before getting into the Q&A session, where hopefully you have some questions, I want you to remember the following. The first one is setting up this collaborative team, really making it consisting of everything from the shop floor up to the data, to the people that have the data demand, because there's a lot of knowledge transfer that needs to happen inside of that team. The second is calculating the business value. This is really something that we see a lot of the times getting missed, that is not happening that much, and it should be focused on more. And the last one is, or the third one is choosing the right technical backbone. As I just presented, you want something that can quickly scale to multiple production sites, because as we learned, when it comes to energy savings, it's actually a potential that is there today and just has to be found. And then you have long-term savings. Every month you're saving thousands of dollars or euros, whatever, in energy there. And then all of these three together is actually embracing strategic decisions when it comes to this transformation, not just thinking about the energy management, but also further use cases, because they all also help each other. If you make other efficiency gains, that will also often result in more energy savings here. And with that, I would say, let's come to an end, and I will be ready for your questions now.
Thank you, Toby. So I think the first question that dropped in here was a while ago from a slide that you presented with the collaboration. I think, let me go back. So he asked, what's SME? I think that was with the business owners.
That's a really good question. Actually, at the moment, not quite sure what the abbreviation means, but I can certainly look it up and tell you then. But
Okay,
we
so
probably have done it in the meantime themselves.
Small and medium enterprises.
Yes.
Oh no, so it's subject matter expert. That's what I found here in our marketing slot.
And I think, yeah, that's what is meant on the slide as well, because we were talking about the business owners or the use case owners. So as I mentioned, for the first case study, for example, having a dedicated person for the energy management, that would be the subject matter expert on this case, on energy management in that case, who has the data demand and wants to have that fulfilled by the IT and OT systems.
Okay, so we have another question coming in here. I think that plays part with the collaboration part. So let me just quickly post this here. How can Connectware support the company's OT and IT team for better collaborative work?
Yeah, at first, like I mentioned, like having this team assembled is like a first step to actually get this collaboration working better. Then second of all, we actually always try to emphasize this more, making the OT, enable the OT to actually take part of all of that digitalization. We often see that as a problem, that OT feels a little bit, not left alone with that, but like the IT is just coming in and pushing their will upon the OT. But actually the OT is really necessary because we still have all of the systems in place, the PLCs and the sensors. So we need the expertise. And for example, with Connectware, we have an upcoming release where we actually want to give the OT like a low-code solution, so they are actually able to connect all of the machines themselves, and then it gets handled in the same way as before. So the OT still has the governance there.
Okay. Coming in with the next question. How can I increase my energy efficiency with the data that Connectware provides?
Yeah, that really comes to, at the end, analyzing all of that data. So Connectware firstly, provides all of the data, collecting it, also enriching some context. Often you have the energy meters or the sensors that measure the energy consumption, not directly connected to the machine, and you need some kind of layer in between to actually map the sensors to the machines, so that you know at a later stage, okay, this energy meter is measuring the energy consumption of that machine. And then it is really a part of later the data science teams to actually look at all of the data and see where there are saving potentials. As we have seen in the first case study, for example, look at, is there actual demand to use that energy at the moment? Is the machine producing? When it's not producing, maybe there's an energy like saving mode, or we can turn the heat down a little bit if it's an oven, and there save some energy.
Okay, going again into energy. How are the interesting data points integrated into Connectware? Is there a good practice strategy to equip the shop floor and other energy consuming areas and devices properly so that a reasonable data-driven energy efficiency improvement can be achieved?
Wow. I have to read that through again. Interesting. Yeah, so I mean, it's multiple questions in one, I would say. So the first one, how are the interesting data points integrated into Connectware? That is through the commissioning files and with the help of the OT actually connecting it. And then we often, to make it scalable, we often have templates that you can quickly use to get the same data points out of similar machines. So if, for example, if you have an OPC UA server, to have like similar data mappings there to actually gather all of the interesting data points. And then the second question, is there a good practice strategy to equip the shop floor and other energy consuming areas and devices properly? Yeah, so if I understand the question right, it's actually, as mentioned as well in the first case study, firstly identifying where is your biggest energy consumption, and then think about, is it worth to like get to the machine level and have every machine connected, or maybe start with the biggest energy consumers that are a lot of the times really obvious, which machines are consuming the most energy. And I would start there. And yeah, I think that's it for the answer. I hope it helped.
Thank you. So I think I'll have to see what's coming up here. Somehow I can't set this free right now, but I can read it out loud anyhow. So what is more important from your experience, collecting more data and evaluate the obvious efficiency improvement targets with the pure and visible data, or statistical approximations and machine learning?
I would say, like, of course, we would like to see more machine learning in place in the factories, but to actually do that, you need data to actually train a model and analyze it, and that's what is missing at the moment. So if you want to get efficient fast, you have to do it at the moment with the visual data and like analyzing it per hand. And hopefully, if you have the data infrastructure in place, later you have the right amount of data to actually start with machine learning and make it even more efficient.
Okay, thank you. I think there has been no further questions so far. So if nothing else pops in, I think we can conclude. I think, do you want to say something about this?
Because the energy management topic, we have a series about that, and I would like to invite you to our next webinar from Lukas Teilacker, the fast track to ESG compliant energy monitoring. I think, Gerrit, there's the date on the 17th of April, again at 10:30. So yeah, Gerrit just posted the link in the chat. Feel free to join there as well. And yeah.
So thank you again from our side. Thank you, Toby, for your insights from all the customers. And if you have any further questions to Toby, please contact him directly or myself, and we can also handle any questions afterwards directly. And there seems to be no further questions here, so we'll end the session right now and hopefully see you in the future for the upcoming sessions. Have a good day, everybody. Bye-bye.
Thank you. Bye.